Here's the try it on your own part of the video for quadratic and linear systems. I wanted to be able to show my work for this one and walk you guys through it because we only did one example on the notes. If you already feel like you know what you're doing from the example, then you don't have to watch this part, or you can just try these two problems and just check for the answer at the end. Just scroll through the video. So this is the first try it on your own example. You guys can copy it down. And I wrote use substitution. I just mean do it just like we did with the example. So for this, I like to put my quadratic on the left. I would say x squared plus 7x minus 15 equals. And remember, we can say that these equal each other because they both equal y. So I set them equal to each other. And now to use factoring, which is what I want to hopefully end up doing here, I need to move both of these to the other side to set equal to 0. So in order to do that, I'm adding x and I'm adding 22. So I'm left with x squared plus 8x plus 7 equals 0. And at this point, you guys can decide what method you want to use to solve the quadratic. Remember, we have completing the square. That would work here because this is even. That b value is even, so it would be easy there. Quadratic formula works for any quadratic, so you can always use that. Factoring doesn't always work, but it would work here, and a is 1, so that would be a good option. You can also solve algebraically with square roots. So you have 4 options to solve. Algebraically would not work here either. So I'm going to factor for this one. A is 1, so I'm going to do my x and put 7 on top and 8 on bottom. And I'm looking for two numbers that multiply to 7 but add to 8. So that would be 7 and 1. I'm going to put those into binomials. X plus 7 times x plus 1, and that equals 0. And remember that zero product property says I can set them both equal to 0 separately. So when I solve, I subtract 7 to get x equals -7, and I subtract 1 here to get x equals -1. So what that gives you is the two x values. Just put it back up with our problem up here. So I have -7 comma something. I need to find that y value. And I have -1 comma its accompanying y value. Now I need to solve that, and you can use either equation. You have an option, just like with linear systems. You can choose which one you want to plug into. Now this one is way easier. You don't have to deal with something squared. It's less terms. So I would always plug into the linear equation for sure. So I'm going to do that twice. I'm going to say y equals -x minus 22, and I'm going to plug in -7 first. So this becomes +7 minus 22, which is -15. So when x is -7, y is -15. And now I'm going to plug in -1. So I'll say -1, or negative times -1 minus 22. And this equals 1 minus 22, which is equal to -21. So when x is -1, y is -21. And that is the answer to that solution, that system, I should say. And the next one we're going to do looks like this. And I wrote use elimination. You don't have to do this. I just want to show you another option. The first thing we're doing when we're solving linear quadratic systems is doing like the system part of it, like combining it some way, eliminating a variable. We need to figure out what the x or the y equals. So you can also use elimination if you wanted to. So I'm going to show you what that looks like. If you wanted to use substitution, how we did over here when we just set it equal to each other in the beginning, you'll get the same answer. That's totally fine. For elimination, you're going to line it up so that all of the terms are lined up appropriately. Just write my quadratic out. Now I'm writing my linear part out, and I want to line up. There's no quadratic term, so I'm not going to write anything there. And I have -4x plus 3. And now I'm going to eliminate. And I want to eliminate the y's, so I'm going to do so by subtracting. When I do y minus y, they cancel. And look at that, it's set equal to 0 for us. 2x squared minus nothing is just 2x squared. -4 minus -4 turns into -4 plus 4, so that term also cancels out. And then I have 1 minus 3, which is -2. So now that I've combined my two equations, I have one quadratic left over, and this is where I'm deciding, do I want to solve with the quadratic formula, with completing the square, with solving algebraically, or with factoring. So you can choose here. For me, I think that probably the easiest way to do this would be to just solve it algebraically, add 2, divide by 2, and do the square root. So that's what I will do here. I'm actually going to move my 0 to the other side. I know a lot of you like to look at it like that better. So I'm going to add 2. So I'm left with 2x squared equals 2. And now I divide by 2. And I have x squared equals 1. And now when I do the square root to cancel out that squared term, I'm left with x equals plus or minus 1. So I have 2 answers there. And what I have is a 1 in the x spot. I need to find its y. And I have a negative 1 in the x spot, and I need to find its y. So I'm going to go ahead and do that now. I'm going to use the linear part again. It's way easier. So I'm just going to plug it in right here. I have negative 4 times 1 plus 3, which is negative 4 plus 3, and that leads to negative 1. So when x is 1, y is negative 1. And now I'm going to plug in my other x value, which is negative 1. So I'll do negative 4 times negative 1 plus 3, and I get 4 plus 3, which is 7. So when x is negative 1, y is 7.